let us get started here.
Okay, well, I'll just do a little quick intro and I'll let you before taking over just to say, hey,
Yep.
everyone. Thank you all for joining. It's GroupBy 2022 in May. It's very exciting. And thank you all for joining us today. We're going to hear Courtney White in just a minute. My name is Deborah Melkin. I'm going to be moderating. If you have any questions for Courtney as we go along, put them in. Do we have a chat? We have a Q&A. I know that some people may be on the GroupBy channel and Slack. I will try to keep an eye, but the Q&A and chat will probably be the best places. So we'll be able to jump in if you have any questions as you go along. It's always great if you have questions and comments. That way we know you're listening and paying attention. But don't want to take too long. But again, if there's any issues that come up, ping me as well, and we can make sure that those get resolved. So with that, I am going to turn off my camera and turn things over to Courtney. And I'm really excited to hear this one, ETL without permissions. So hopefully y'all are too.
All right. Well, good morning, everyone. My name, of course, is Courtney White, and thank you all for joining me here. I'm going to go through some of our quick administrative stuff. As a reminder, the GroupBy Code of Conduct, the highlight here is, of course, we do not tolerate harassment in any form. And a thank you to IDERA for being our media sponsor. All right, so all of that said, welcome to ETL without permission, bulk loading data quickly and easily without elevated permissions or expensive tools. My name's Courtney White. As I said, I have been working, well, I've been doing computer programming since probably 1994 in one form or another, although I'm not sure how much making little text-based games in BASIC counts as programming, and certainly not database work. I've been working with databases since 1997 or so in one form or another. I started in the Microsoft Access world, and that has still been a significant part of the work that I've been doing for the last 25 years. Microsoft Access is actually, it's one of those tools that gets a lot of crap from SQL Server people, and very often for good reason, because it's a tool that's very easily abused. But it's also one of those things that's ubiquitous in the business environment, and it's something that can be a first introduction for good or for evil for for a lot of business people out there who then may transition into the into development work or even eventually database administration. And indeed, that's more or less what I did. The inspiration for this talk actually comes from coming from a Microsoft Access world where the majority of my greater work group was working with about 500 different Microsoft Access databases of various levels of complexity that had to interact with half dozen or so enterprise scale databases split more or less equally between SQL Server and some Oracle databases. In my day-to-day work right now, I do a lot of work still in SQL. I'm mostly working on a project, a C# project right now, but that really heavily interacts with databases, and I do a lot of process engineering work. As it says in my little bio there, I am accustomed to almost never having the right tool for the job. For years, when I first did this transition, I couldn't get my hands even on SSIS, let alone the permissions to run it in order to load data to a SQL server, much less something that actually costs money, like a Toad or something else. So we started doing some workarounds, and I'm at the point now where I can say pretty confidently that my workarounds are outperforming Toad or SSIS, at least in my environment. So solving these sort of weird edge case problems is something I'm really passionate about, and I hope many of you are too. I live in Baltimore, Maryland. It's currently not living in my home. It's being demolished right now. They took out some walls yesterday, And so I'm squatting with my my parents-in-law, who are very kindly allowing me to be here. And I have two kids who are at elementary school right now. Share just really quickly. I don't have the view of the Isle of Wight, but I do have a view of this, which is sideways, but it's the little thing that they put together for me this morning because today is my first conference presentation. So lucky all of you. Hopefully it doesn't show too much. Anyway, okay. So moving forward, I will say that I do have one other presenter who may or may not be showing up. My cat, Baron, he's currently sleeping, but if the screens start going crazy, you'll know that he's joined us. I know normally we talk about resources at the very, very end of a presentation, but I know I might lose some of you, and I want to make sure that you get something out of this presentation, even if you just stick around for the next 60 seconds. These are all resources that I actually use. So, of course, we have sessions from past conferences. One of the things I love about GroupBy is that we can go and see replays of any of these things, and I've watched a number of them since I first discovered GroupBy back in 2019. I can't promote the SQL Data Partners podcast enough. I'm affiliated with it in 0 ways, completely unaffiliated. But Carlos El Jacon has done some really fantastic stuff there, and it was really a gateway for me in getting into some of the wonkier, more technical aspects of working with SQL Server. Of course, Brent Ozar's blog is, again, super fun when it comes to some of the weird little edge case technical things. And if you're actually a serious database administrator, I'm sure you already have it bookmarked. Local user group events, we have a few of those around here. I encourage you, if you haven't reached out to others in your community, to find a SQL Server user group near you. SQL Saturday, as it's coming back now, as we hopefully are moving out of the world of the pandemic. I've only had a chance to attend our local conference back in 2019 here in Washington, D.C. It was a great event. I encourage you to check those out if you have the chance. And finally, the code for this presentation is available at on my GitHub page, which you can get to from code.cursorsareevil.com. Okay, so I'm going to run through really quickly some of the approach and principles here to what we're trying to accomplish, which is, again, getting data onto a SQL server with in as expeditious a way as possible and as easily as possible. So minimizing network operations. Of course, as we all know, when it comes to the hierarchy of slowness on many of these machines, the processor and memory get to play around with things really quickly. We try to minimize our I/O because disks are relatively slow, and then network operations are typically multiple orders of magnitude longer. It's all too common to have a 1-second network operation, but you should never see that with memory. We're going to prefer sets over rows. I'll talk a little bit more about that later, but as a general rule, we're going to try to work with everything in a set-based way. As I mentioned, cursors are evil. We want to minimize resource contention to the greatest degree that we can. We don't want to end up with situations where we have deadlocks or where we have a lock or a latch on a table and we're preventing other people from doing work because it's exclusive, or even in some cases because we have a shared lock that's preventing writes if we have that lock for a really long time. So some of the things we're going to be doing here is going to be to really try and minimize that. We want to try to perform expensive operations exactly once. That might seem really obvious, but when it comes to working with really large data sets, and I'm not going to be demonstrating a lot of really large data sets here. I think the largest set I have in the demo is only about 10,000 rows. But that's because I'm running all of this off of a local instance of SQL Server Express. We we have used these techniques for millions of rows and millions of rows containing a lot of data. So when you're performing, going back to that same data and having to load it into memory again and perform multiple updates on it only to unload it and then load it again, it really can add a lot to the time. Related to that, we're going to prefer large batches of work over small batches of work. So if we have to load, say, rows, we're going to try and load 1,000 at a time rather than one at a time 1,000 times. We are going to use our knowledge of the data and the structure to optimize queries. Unlike, and this can be a bug or a feature depending on how you look at it, unlike some of the tools like SSIS or like a Toad, this process is often going to involve actually handwriting some SQL to get data transformed and placed in exactly the place that you want it. We want to load only what we need. Again, that may go without saying. There are going to be some cases where the performance impacts of throwing an extra column or two up onto the database are going to be minimal. And there may be reasons that maybe just for ease of administration of your different processes, maybe sometimes you're going to load a couple of extra columns that you don't need. But for the most part, we're gonna really try and pare that down. If we need an index, we're gonna add it. In case you haven't guessed at this point, we are going to be dealing a lot with temporary tables, primarily user scoped, single connection tables, your single pound sign temp tables. And we're going to index them as necessary. Okay, so let's talk about what the steps are. So first, obviously, we're going to get our data from whatever that source is. And that data source can, for these purposes, can be anything that can be loaded into basically a record set. The demo I'm going to be doing is going to be using VBA and ADO. I will put the .NET version of this up on the GitHub site within a day or two. I wasn't super happy with it, so but I will have it up there as well. It works just as well there, of course. So once we have the data, we're going to perform any local transformations. I was speaking with our primary database administrator for one of the databases that I work with, and some folks from another team on a call a couple months back, and one of the people on another application team had said, had asked the DBA about getting some extra permissions because she needed to do a bunch of modifications to some XML that they were going to store for whatever reason in some of these tables, and they needed to be able to pull it down, and they wanted to they actually wanted to add some CLR functions to the database in order to manipulate it in place and so forth. And and I knew she was actually mostly a Perl programmer. And that's one of those times where if you're going to have to pull the data locally anyway, and she did, use the tools that you have. If you have a strong API that lets you modify XML, and most of us do, or JSON or something like that, you can do it in pure SQL. I mean, there's no question about that, but use the best tool that you have available for the job. If you're pulling it local anyway, do your modifications locally, perform whatever those expensive transformations are going to be on your machine, or on your data processing machine, whatever that might be, whether that's your desktop or something else, and then work from there. Anyway, then we're going to go ahead and create our temporary tables on our destination database. Add any constraints that are necessary. In this case, the constraints we're talking about here are going to be the constraints really to validate the data as it's going in. And this is so you can error out at the beginning of the process rather than at the end of the process if there's something that you're not taking into account. For example, if you think that you're loading something that's going to be a primary key field, and it turns out that it has duplicate or null data, that sort of thing. So once we've created the temp tables, we'll add constraints. Then we're going to insert the data to the temp tables. We are going to then index the data as necessary. More on that in a little bit. Generate our final data set, and then we're going to load it to the target. When I say generate the final data set, just as there's some transformations that you're going to want to perform locally, there are other transformations that are going to be better performed on the SQL Server. If you are trying to resolve to a key that is housed on the SQL Server, very often, index your fields correctly, join over to that type table or whatever it might be, and that's going to be the faster way to to get those key values rather than loading something up in a dictionary locally and iterating through it. So you can do a number of different manipulations to those temporary to the data that's in those temporary tables. Sometimes you're going to be, creating additional temporary tables as a part of those transformations before we do our final load to the target. It's important to keep in mind that whenever you can, you want to match your primary and unique keys on the target table to indexed fields on the temp tables. Now, you don't always have control over, in fact, you often don't have control over what fields are already indexed on the database. Some, if you're a member of an application team that owns those tables, then, obviously, by all means, index appropriately. I have certainly been in circumstances where I don't own those tables. I don't own that data, and for whatever reason, it's not possible to get those indexed. But the temporary tables you control. You can always add the indexes there. There are some edge cases then where it's actually going to make sense to take your target table, and you might end up spooling that over into a temporary table just so that you can index it. And I will say that there have been times where I've had multiple orders of magnitude performance improvement just because I'm able to do a join on a field that I indexed on a temporary table compared to trying to join back to an unindexed field on a target table. Okay. So these are the different kind of tools that you're going to use for the different steps, local transformations you're performing with local code, creating your temp tables. You might be doing with pure SQL, you might be doing it with code, you might be doing it with a combination of the two. Adding constraints, of course, is SQL. Inserting the data, you're going to be doing that client side with code in order to create those insert statements. And then the rest, of course, is SQL. So let's talk about some different approaches to how we can do that. For starters, we have what I call the naive approach. This is one of those things that I think that you see most commonly if you are working with a non-technical or a less technical team. They start by working with one row at a time. They're going to be using very often cursors or loops. Now, that cursor may or may not be server side. Now, this isn't to say that cursors and loops are always bad. Cursors are usually bad, but they're not always bad. But this approach is something that's really common in non-SQL languages because object-oriented and procedural programmers often think that way. In fact, I would say that tools like LINQ make it so easy to work this way that they practically beg you to do it. If you're reading from arrays, for example, in order to pass their values to a database, it makes perfect sense to loop through that array. But sending the instructions to the database that way really is not optimal. We're going to be using either dynamic or parameterized SQL or a combination. It really doesn't make a difference from our perspective here, whether you're using dynamic or parameterized SQL for the naive approach, though ironically, it's actually a lot easier to fall into the looped cursor trap when you're using parameterized queries because they typically have exactly one row of parameters defined. Implicitly, this is how a lot of applications do it. It's interesting that tools like Microsoft Access, for example, here we go back to one of the reasons it can get kind of a bad rap. One of the reasons that performance can be so lousy when you're using the Access query engine to update something, even on a ultra fast SQL server with all the memory and solid state drives and all of that, is that under the hood, it's actually submitting things one row at a time as a part of a transaction. I assume various different tools do it that way because the approach is pretty fault tolerant and relatively easy to implement programmatically. Honestly, my original impetus for getting into this kind of work was my outrage at how long Microsoft Access was taking to perform a simple set of updates on a linked SQL Server table. Once I realized that what it was doing was beginning a transaction and then sequentially sending one row of data at a time, even when I'd taken the trouble to use an update query that was supposed to do everything in bulk, that's when I became fully committed to bypassing the Access query engine and doing everything myself, which was how I started working on this project back in 2016 or so. Some of the features or bugs, depending on how you look at them, of this approach include you have repeated network calls. When you batch your data, that's going to be reduced. But if you're going one row at a time, you're sending something over, waiting for a network response, and then sending the next thing over. And that latency, just the latency alone can really add up. You do have repeated I/O calls. Every one of those insert statements is forcing the table to be loaded back up, some portion of it into memory, and then you're going to write it down to disk or to memory, as is usually the case with TempDB. But there's still that I/O overhead. And batching these single statements really doesn't help. You send 1,000 separate insert statements to a table that has, for example, a clustered index. It's going to have to perform 1,000 separate updates there. If it has additional indexes, it has to perform 1,000 separate updates to those indexes, as opposed to if you send all 1,000 at once, yes, it still has to make updates to 1,000 pieces of data, but it can do them all at the same time. It doesn't have to load that index 1,000 separate times, find where in the B tree it's going to load the data, and so forth. Also, usually this approach is both synchronous and sequential. You're sending one row, waiting for it to be processed, then you send the next row. That also can really add to time. On the upside, though, is that the query plans can usually be reused, especially if you're using a parameterized approach here. Insert into whatever, question mark, question mark, question mark, question mark, if you're using the ODBC syntax or whatever it might be for your parameters. We just run that over and over again. So next approach, which is what we're going to really be looking at here, is the batch approach, where we're going to be sending multiple rows at a time. Of course, there are a lot of different ways that you can send multiple rows at a time. We could do multiple rows in single statements. We're going to try and avoid, or multiple single statements, rather. We're going to try and avoid doing that whenever we can, because that just falls back to some of those same problems with the naive approach. You can do a single multi-row statement, or, of course, multiple multi-row statements. Now, informally in my testing, I will say that usually, and I thought this was a little counterintuitive, usually with larger data sets, I find that the multiple multi-row statements end up working out a little bit better. So I might not have ever realized that were it not for the fact that values is limited to 1,000 rows. Now, of course, if you're committed to doing everything in a single statement, you can just union all a bunch of selects, or you can use union all select from values, and union up your various different value statements in order to submit, say, 10,000 rows at a time. Again, as I said, for my testing, my experience is that the performance tends to be not great on that from looking at the query plans for whatever reason. SQL Server seems really committed to sorting the data, despite the fact that we're using a union all here. I think that's the cause for the overhead, though I don't know for sure. And I encourage you to test it in your own various different use cases. This is going to largely use dynamic SQL, which means, of course, that you have to take some care to avoid SQL injection. We will talk more about that later as well. So features or bugs, as the case might be, one network call per batch. That can really make a difference. Going from 1,000 network calls to one network call is huge. If you were doing multiple multi-row statements in a single batch, you could have 100,000 rows being loaded as a single batch, and the time savings there are really significant. You have one IO bundle per statement. That is all of those things that have to happen whenever you're doing an update or an insert or a delete, index updates, and so forth. Creating the batches is relatively slow. Really, they generally create faster than the SQL Server is going to process the rows. Not a lot faster, but faster. And again, your mileage on that might vary. Individual server operations are going to be relatively slow, particularly as those tables get larger. Yeah, particularly as the tables get larger. Heap tables seem to perform worse in my testing, though again, your mileage may vary. So sometimes you may want to create the primary key at the outset, sometimes you may not. One of the unfortunate things here is that individual query plans are probably required. You're using dynamic SQL. Basically, every single batch that you submit is going to have, statements that are in no way the same as any of the previous ones. So adds a little bit of extra overhead. Really not that bad in the grand scheme of things, but again, test. Okay, so before we go into our first demo, let's talk about my favorite section, which is the weird approaches. These are things that I'm not going to be demonstrating here, not because I don't love them, but because it's really complicated to put together a good demonstration of it. And they are really for edge cases. So for starters, we have tokenizing duplicative inputs. What on earth do I mean by that? Well, so I have an employee table that that consolidates, I don't know, it's got probably 150 different columns of data, including not just people's names, but where they work, like the particular street address of their office or what the name of their department is, and all sorts of things like that. And when you start adding up all of the text in that, you have individual rows that are, I don't know, probably something on the order of 900 bytes, something like that, sometimes more, of text information. Now, of course, I don't need to load all of that. In this particular case, I needed to load information about who the employee is, their email address, their manager, where in particular they are working, like what their office is, what their job title is, and what departments they're members of. Well, certain elements of that are going to be highly duplicative, right? So job title, there are probably 100 other people in my organization who have the exact same job title that I do. And when it comes down to things like tellers at a bank, maybe you have 80,000 people who have some sort of teller related title. So what I did with these various different things is resolved those text fields to a number. You create a reference table for it, and then instead of the division name under which I was at the time, Wells Fargo Commercial Capital Chief Operating Office, something like that, which is long, right? You have a number, an integer, and that can be surprisingly a really good way to get some performance improvements. I went from loading like 350 megabytes of data, something on that order, to down to around 45, I think, in order to do this process just by tokenizing the inputs. Again, it's an edge case. It's not something that's going to come up that often. It's kind of awkward to write, but it is a tool that should be in your toolbox, something to think about. Speaking of that, then of course, there are the JSON and XML inputs. Why bother transforming all of this into a data set and then transforming the data set into a select statement or an insert statement rather, when you could just extract all of the data as JSON or as XML and send it as a single parameter? And I mean, the answer to that is, of course, that the JSON is huge. The XML is worse. And at least in my case, I was able to get my UAT SQL Server to seriously choke on some medium-sized tables, transforming those into JSON, I assume because the string concatenation it has to do, just, you get to the point where the strings are so huge that the overhead of having to move them or copy them, move them around in memory in order to form those huge strings just became absolutely enormous, so big that the server started really choking on it. And I went from being able to get a data set, all of the rows, all of the columns in, I don't know, 7 seconds, something like that, to waiting multiple minutes for a JSON string. So there are definitely reasons to avoid doing this. And then, of course, you have the network cost of sending that enormous string over the network, which is probably going to be bigger than your insert statements. Of course, the way around that is to compress or decompress your strings using those lovely functions on the SQL Server. I have played with doing this. It's more super fun because you think you're really clever that you've come up with this. At least that was my experience. I felt super clever that I thought of compressing the string and then decompressing it, because CPU power is cheap, memory is relatively cheap, but network IO is expensive. But it's kind of, unless you're dealing with really big data sets, it's probably not worth it. Slightly more worth it might be compressing your batches that we were doing from the multiple rows per batch approach, compressing that SQL down, and then server side decompressing the string and doing an SP execute SQL on that decompressed SQL. There you can get some performance gains. But again, it's a little awkward. So unless you have a really big data set, probably not worth it. Other options, proprietary formats. Yes, you can write your own proprietary format of data that you're going to send to the SQL Server. Don't, please don't. Open formats. I was looking at one point at taking the binary format. You can serialize ADO record sets into binary, and the specification is all on Microsoft's website, and that's great. And it's a huge amount of effort, and there are so many other solutions that are just as good. So unless this is a format that already exists on your database for loading these things, or something that you're going to reuse over and over and over again, don't. It's the performance gains you get are likely to be very minimal. Micro optimizations. Yep, you can eke a half second off of your data load operations if you really put your mind to it. And I do put my mind to it, but I really try not to. You should also try not to. It's not worth 8 hours of your time to save even 10 seconds on a daily ETL process. Please don't. If you're working on this, you're very valuable to your organization. Do something else. Okay, on to some quick performance considerations that I want to mention before we go into our first demo here. Merge versus delete, update, insert. Look at the performance. There are some cases where you need to use a merge statement as opposed to an insert or an update statement. And you'll see that in the demo, actually. But compare the performance. Sometimes a merge is going to perform better than multiple statements that use delete, update, insert. Sometimes it's not. Just test it out. If you are going the merge route, keep in mind that merge statements are one of the most elegant ways to thrash all of the data in your database. Yeah, so be careful with them. Watch your locks. You want to minimize your exclusive locks on production tables. Please, 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 please make sure that when you're writing to a production table that you are doing it in as expeditious a way as possible. You want to have as little additional computational or IO overhead on those operations, or you can very quickly bring multiple systems to their knees. Again, obvious, still worth stating, I think. Do keep in mind that sometimes 2 locks are faster than 1. Sometimes you are better off getting a lock to do something and then getting a second lock to do something. Not only does it allow other people to kind of move past you if there's a risk of stuff queuing up, but sometimes you will actually see better performance. And remember that even shared locks can cause problems if the query is slow enough. This comes up in sort of our bonus content, but I will say that we have well, I don't work with it any longer, but we did have a database that did have some linked server relationships, and there was a reason that you would want to join data from one database over onto the other database. They're not co-located servers, but even if they were, still, it was at least a quarterly event that someone would cause massive queuing on that server, massive backups. Well, why? Well, they don't have read-write permissions on these servers, but they are the primary production servers. But thinking, well, I'm not doing any writings, I'm not getting any exclusive locks, anything like that. They thought, well, so it's fine if I just join this table from my production database over to this massive set of data on another production database that's remote from this one. Well, the problem would be that they would start getting some data back over that linked server connection, which would acquire a shared lock on the production table here. And that shared lock allows all sorts of other reading. No problem with that at all. But what it doesn't allow is those write operations. And so what we would start to see would be that a write operation would start going to update a single row. And sometimes it would be able to get a row level lock on that because we don't have a shared lock on the entire table. We just have the shared lock on a portion of this table, right? So if you have 10,000 records, maybe only 100 of them right now have the shared lock. So the process that's going to write gets a lock on one row, but in a minute, what it's going to try and do is perform multiple other updates as a part of that, as a part of the same transaction. And it's in fact going to try to escalate to get an exclusive table lock here, which it requests. It gets the intent table lock, whatever you call it. And so now what is happening is it is waiting behind this linked server transaction to get that table level lock. But every other read request that's coming in is no longer able to even get the shared lock on the table because now they're waiting in behind that write. Hopefully this sort of makes sense. So now you start ending up with lots of select queries queuing up behind an update that is queued up behind a select. And that first query is going to be waiting a while because of network I/O. So again, maybe this is an edge case. Maybe this is the only place it's ever happened in the history of SQL Server. I have no idea. But I will say that it's one of those things that can be a real bear for people to troubleshoot. It was something that our DBAs really struggled with because because it doesn't make sense to them that that a select query could be blocking workflow, could be blocking other transactions from completing. And if there are other downstream transactions, other downstream operations rather, it's can really bring things to its knees. So anyway, just something to be aware of. Watch your logs. Okay, having said all of that, let's go on over to our SSMS demo here. I'm going to pull that up here. And as I said, all of this is available on GitHub. So we're going to use everyone's favorite Northwind database. I'm going to start by dropping the existing Northwind copy database and then recreating it. This is just it's a copy of Northwind's structure, but no data, which I will prove here. Right, so no data in there. Okay, so we've done that. Now we're going to go over and I'm going to just pull this one up. This is what we're going to use to reset after we run our script. Just again, so you can see, we're on Northwind copy, no results in any of these. Okay. Now we're going to go over to example number 1. So I'm going to run through this in brief without getting too into the weeds as far as the content. You're more than welcome to look at the script, but what we're going to be doing here is we're going to be grabbing data from 2 different tables on the Northwind database. Now, I know this is hardly real ETL stuff, right? We're just taking it from one database to the same database. The point of this is actually not this part up here that's selected. It's not the select into. No one cares about that. It's this other stuff. This is the stuff that you do in order to load the data from the temp tables, however you get the temp tables there. So we're going to go ahead and start by running this so that we now have our suppliers and our view temp tables. And let's just take a quick look at those. Right, okay, yay, temp tables. That one's got 29 rows, this one has 69, I think. Yep. Okay, so what we're going to try and do here is we are going to create, we're going to load the data into 3 target tables. And those are the category table, the product table, and the suppliers table. So these are the 3 different data sets basically that we're going to be loading. We have our suppliers here, various different information from them. That, of course, came directly from the suppliers table. So, this is almost pre-normalized for us. But then this other thing here, alphabetical list of products, that's a view. And so we're going to be loading as much information as we can from that view in order to get the product information here. So here we have the various different products, foreign key relationship with supplier ID. They also have a foreign key relationship with category ID that is missing here because I simply forgot it. when I was writing this demo. It is definitely in the one for merging, though, which will be our next one. Okay. So for this, we're going to assume that we're going to be loading the data without having to account for identity fields that could change our primary keys value, right? So you're doing this if either A, your primary key isn't an identity field, and then you don't need to worry about doing an identity insert, or if for whatever reason your DBA has for some reason given you alter table permissions on these tables or on the schema, which means that you can do an identity insert, in which case I'm not really sure why you're in this presentation, because it seems like your DBA is giving you the keys to the kingdom, but we're going to just go with it. Okay, so we are going to be using identity insert here, but the reason that we're using identity insert is just because I am too lazy to change the primary key fields from being identity to just normal integers. So we're going to pretend that the identity insert isn't there. We start by doing our various different data validations here for our suppliers, getting what we need to out of our temporary table. We want to make sure that the supplier ID doesn't always exist. And in this case, we're also gonna try and make sure that that we're not also adding suppliers that are exact duplicates other than the primary key, and then we're doing an insert. With categories, same sort of thing. We're deduping and then just inserting. And then finally with products, we do the exact same thing and perform the insert. So we go ahead and we run this, yay, did a bunch of stuff. And now we can go and look at categories and products, and yay, they have data, hooray. And then just for simplicity, I am going to roll this back so that I don't have to delete everything from it. So that's our basic insert script, super simple. This is maybe the majority of cases. You just need to make sure that you're not inserting duplicate data. Maybe you have to index something, maybe you don't. In this case, we didn't because the data sets are just so small. All right, not super interesting, but probably a lot of use cases. Okay, then we have the more interesting question, which is how are we going to do this when we don't have control over the primary key? So data could get renumbered on us, but we need to make sure that we are that we're properly correlating our data. We want to relate the product back to the actual supplier, whatever it's called or whatever number it's given by the database. We want to make sure that that number refers to the same supplier that it refers to in our original Northwind database. And for that, I don't really know of a better way of doing this than using a merge. That's not entirely true. You can do an insert and then I suppose join back up on all of the fields, or do an intersect, I guess would be an easier way of doing it maybe. But this is by far, in my opinion, the easiest. Just a note on syntactical stuff here. This little thing where you see a comment, an inline comment, and then the bang begin section or end section. That's just to tell our text parser in the programmatic version of this to ignore this section. So it's not going to be running any of this. Okay, so what are we going to do? We're going to drop our temp tables. We're going to repopulate them just as we did before. That's exactly the same. Now here we have a couple of additional temp tables that we are also going to drop at the outset, of course, and then we are going to create them. Now, before we'll get to that here in just a second, we are also going to index these tables. We didn't do that the first time because we didn't really feel like we needed to. So we're going to come in here and we're going to check and see if if the field that is the current primary key, or well, that is our candidate primary key, supplier ID, see if it's nullable or not. If it is, we're going to make it not nullable. Now, we don't need to do that for this example here, right? Because when we do the select into, it's going to exactly duplicate those field definitions. So supplier ID will not be nullable, and this isn't going to do any work when we run the script here. However, when we do this programmatically, the way that I have the code set up in that other example that we'll see shortly is that it errs on the side of allowing data to be nullable. So it's going to, when it creates the table, supplier ID will be nullable. So we have to make it unnullable anyway. So we do that, and then we have this. Alter table suppliers, add constraint. What is this? Primary key supplier's ID. And we're doing this with dynamic SQL. Why on earth would we do it with dynamic SQL instead of just the way that we did this up here, just doing an alter table, add constraint? Well, the answer to that is that constraint names, or at least key constraint names, I haven't checked with defaults and I don't recall from the documentation, but key constraints must be globally unique, must have a globally unique name in your database. So if we plug in a constraint name when we're doing the alter, and if you're doing an alter, you have to provide a constraint name, not like when you create the table where it'll just get system assigned. What if someone else is running this, or someone else is running something else that chooses to duplicate that constraint name? Then you run into problems and your script will crash out right here. So we're going to just generate a new GUID, and we're going to use that to come up with a ridiculous name for our primary key. Then we do the same thing for the product. Then we're going to come down here and we're going to create our indexes. Now, unlike those constraints, indexes just have to have unique names across the object that they index, so we're not worried about name collisions here. Okay. Now, those temporary tables those additional temporary tables, supplier map and category map, these, of course, we're going to use to map the primary key that's coming in. So the primary key, according to the data that we are loading, we're going to map that ID over to the primary key that is generated when we load the data into the destination table. So, for example, we pull supplier ID number 1 out of Northwind. We load it in here, but the next available number on that identity field is 9. So it's going to be loaded as a 9, as supplier ID number 9. So old ID then is going to be 1. Supplier ID is going to be 9. Same deal for category. Now, we don't actually need to use product map because we're not loading anything that references it as a part of this, right? Nothing's referencing product IDs, so we actually don't care what keys, what IDs product ID is given, okay? Then we move in. We're going to start with suppliers, just as we did before. And so that we can see what's happening, I have some text input output when we run this. So we are going to delete any supplier that already exists from our temporary table. So if there's a true duplicate between what we're trying to load and what's already there, we're just going to remove it. This is part of the principle of touching your data exactly once if you can. Save us some work down the road. Again, with this data set this small, it doesn't matter, but for larger data sets, it can. Then if we have something that matches exactly, except for the supplier ID, we want to remap it to point to the actual supplier ID already in the table. So in other words, if Joe's crabshack.com, whatever, who knows, joescrabshack.com, why do they have a .com? They just do, already exists in the supplier table, and it has an ID of 2, but in the Northwind table, it has an ID of 14, and the name and the contact and everything about it is exactly the same. We're going to go ahead and say that that is in fact the same supplier. Okay. And now for the fun. So we are going to do a merge, but we're going to do a merge that forces an insert. so that we'll be able to get the original supplier ID and the new supplier ID out so that we can do that mapping. How do we do that? Well, we're going to start by grabbing all of the suppliers that aren't already mapped, because we could have mapped something here. The sensible thing to do actually now, well, conceivably, if we'd put this before the delete, we could have actually also deleted anything that's already mapped. So maybe that would perform better. But okay, so we're only going to get the suppliers that we actually for real want to insert. And this is important because when we merge, we're merging on 1 = 0. So we're never going to get a match. When not matched by target, then we're going to insert the values from our source table or source CTE, and we are going to output. This is why we use a merge right here, source.supplier_ID and inserted.supplier_ID. You are not just confined to using deleted and inserted in your output clause when you use a merge statement. You can also use the source data. And we're going to put that into our supplier map. And so that will give us the mappings of old to new. Okay, then categories. Category and product is in a single temp table, so we can't do the delete thing that we did before. We're going to have to actually just filter everything like that out. Now, if you need to minimize the duration of exclusive locks on the categories table, front-loading some of the data comparison is one way to do that. This is an example of another case where, an example of another case where doing this might make sense. Is if the category name wasn't indexed on a large table, although indexed or not with only 8 nvarchar 15 records, it really doesn't matter. That's all going to load into just one page. So an index doesn't actually help here. But we're going to demonstrate it anyway, because in larger cases, it might help. So we're going to go ahead and create a new table, category paranoid way. And we're going to index category name, and we are going to insert category ID and category name into it. Now you might be saying, wait a minute, the more efficient way to do that is to create the index on the back end. And you're probably right if we were doing multiple operations, but we're going to have to update that index anyway. So we're going to just leave it there. If we were doing multiple inserts, we'd create the index last. Since we're only doing a single insert, the performance should be the same if we do it then. Okay, now one of the things that's easy to miss is that the structure of these tables doesn't actually make sense considering business circumstances. How often do you have a category table where there are multiple category names that are exactly the same? That doesn't provide a lot of information at all. That's just confusing. So you see something like that, you consult with the business, confirm that it's supposed to be unique, regardless of what the database says. This is really just a reminder that business logic can really be more restrictive than the database logic. And that you want to make some common sense or use common sense when you're making some of these decisions. So anyway, they agree that category name should be unique. So we're going to go ahead and work under that assumption here. We will map over our exactly matching categories using our category names here. Now, we don't want to map them over if the category ID is exactly the same, because then we're just not going to insert them. But if the category ID is different and the category name is the same, we're going to go ahead and just add that to our mapping table. And then we'll go ahead and load again using merge, using 1 = 2, so that we can force our insert and get all of that. Of course, we excluded anything whose category name is already in our category paranoid way table. So if the category name is already there, we do this. Now, as I mentioned, one of the reasons that you might do this would be now you're not having to read from the table. You're not having to read from a table that may not have an indexed field. And perform updates on it at the same time. Not that your read is going to interfere with your write, but the point here is that you want to try and get your latches or locks on this on the actual underlying table for as little time as possible. And so we'll do this at the the beginning of the query, filter out all those records, and then the engine's going to go and start looking at DBO categories. Okay, and then finally products. This one is actually surprisingly straightforward, I think. The big thing to remember here is that if there's a mapping, right? If we have a mapping for the supplier ID, we want to use that. That's what this is, supplier map. If we have a mapping for the category, we want to use that. Otherwise, we're going to just go ahead and use the supplier ID or the category ID that came through from the Northwind database. And blah, blah, blah. We want to exclude anything that is already there exactly the same as before. And now we're going to just do an insert. We don't have to do a merge because we don't care about those primary keys. So that's what's happening. We're going to go ahead and run it. And here we go. We've got our data, 69 rows for the product, 8 for the category, and hopefully 29 here. 29 rows for the supplier. You'll notice that the supplier IDs here are different because even though we rolled back those transactions earlier, of course, those identity values were already generated. Now, if we want to be really paranoid about this, right, we can look and see what happens when records are partially present. So what we're going to do here is we're going to go ahead and select some records, more or less at random, that we're going to remove from the categories and suppliers tables. And of course, we have to remove the corresponding records from products. So every other one is going to come out of categories, and then every third one out of suppliers. Run that. Run this again. Our numbers should be different. So now we have 24 products, 4 categories, and only 20 suppliers. Okay, so we've eliminated some. Our highest number of suppliers, 58, 15 for category, and 131 for product. We can run this script again, and it does not care that we just did that. It's still going to load all of those, and we're back to 8 categories. We are back to 29 suppliers, and we are back to 69 products. So it managed to do all of that, even though we, at random, deleted data. Now, of course, if we go back to our reset script here, right, run that, we see there's data. We run our reset script again, we're reseeding those values. Now we run it, and of course, we get those supplier, all of those IDs starting at the beginning. Okay, so that's our SS.
Hey, Courtney, I don't know if I just lost your sound, if that's just me, but I did want to give you the Courtney?
1 hour, thank you.
Yes.
So half an hour to go. You want to use excepts to eliminate meaningless updates, and this is a rare time that it's good to DUI. Do your deletes first, then your updates, then your inserts to minimize the number of touches to the data that you're performing. Okay, before we go into the Excel demo, let's look at what the code in our demo is going to need to do. First, we have to identify our data types. We generate our DDL, and then we're going to start generating our inserts. As we complete an insert batch, complete generating an insert batch, we're going to go ahead and post it. And then as that insert batch completes, we'll go back and we'll post the next available insert. So in other words, here's the way to think of it. We're going to generate 1,000 rows worth of inserts first. And as soon as that first batch is ready, we're going to go ahead and start inserting it. While that 1,000 rows is processed by the database engine, we're going to be generating more inserts. And every 1,000 rows, we're going to check to see, is this, I'm sorry, I'm drawing with my mouse on the presenter screen. So every 1,000 inserts that we generate, we're going to come over here and we're going to check and see, is the last batch complete? If it is, then we're going to post as many batches as we have ready over to the database. So 1,000 records the first time, then whatever amount of time it takes, maybe our next batch is 3,000 rows. Then however long that takes, it's probably going to be longer. So then the next time we might insert 6,000 rows. And then once everything has been inserted asynchronously in parallel, we're going to go ahead and end the process and everything's loaded. Okay, and now we go to Excel. We're using Excel because it is ubiquitous. That is the big reason to do all of it, to do things this way. So I'm going to also pull up SSMS here. We'll jump back to this. All right, we've cleared everything out of Northwind copy. We can see that it's empty. And now we'll jump over here and we're going to just hit this and I'll show you what it's running in a second. And it says that it's loaded the data successfully. We will be the judge of that. 69 rows, 8 rows, 29 rows. It's loaded everything exactly as it's supposed to. Yay. Okay. Let's take just a quick look at what it's doing here. Now, I recognize that probably most of you in the audience eschew VBA programming, and I get that. It's one of those languages that can be used to do terrible, terrible things, and not in the way that I like to do terrible, terrible things. But again, it is omnipresent in the business environment, and it can actually do a lot of really cool stuff if you play your cards right. So all we're doing here, we've got our connection string here. So we're going to load up that merge script here. This was that thing with the comments that I mentioned, the comment bang thing. We are going to go ahead and run the exact same 2 queries that we ran before, except we're just doing a select star from them. This time we're not doing an insert here. And this process is going to go ahead and do all of the loading. It'll pull the data down, jump over to it. So again, this is just pulling the data down. Then we're going to eager spool it to our client. That's what this is doing. So it's pulling down all of the records in bulk to minimize network latency. Then we create our temporary table, which is what's happening here. And I'm sorry, yeah, those are the temporary table objects. We create our temporary table here using all of the fields that are in our query, and then we are going to populate the table there. So, okay, yay, super exciting. We can load that data, great. Well, let me show you just really quickly. This was what I used at the very, very beginning as I was testing all of this out, because in fact, this little library here has support for every different SQL Server data type, which I will tell you, figuring out the binary representation of date time to and date time offset and stuff like that. I mean, it's documented, but it's not very friendly. Anyway, so this little query that we just loaded, and I'll go show you what's in it. It's nothing very exciting. Actually shows us the operations as they're happening. So we're sending, at that point, we sent 1,000 rows. Then we're able to build up to the 4,000 mark of our 10,000 row data set before it's ready to send, because that other batch is completed. And then we build all the rest of our 10,000 rows, and we are left having to wait for a second or so before we can send that last set. And then it finally completes here. So it took 8 seconds to load 10,000 rows. I'll show you what the 10,000 rows are. But everything asynchronously. Let's see. The name of this query, of this temporary table is ridiculous. I don't remember what it is, so I'm going to look. Yes, dbo.temp table. Why did I do it that way? I don't remember. I was just being silly. So it's actually, oh, right. And that is in demos. So this is the data that we just loaded. A lot of garbage, but time formats all work. So that's super exciting. This library too, if you're interested in such things, is also available on my GitHub under VBA_ETL is I think what it's called. And again, you can get to that just from code.cursorsareevil.com if you're so inclined. Okay, so we can load from one database to another. That's not all that interesting. Maybe more interesting is our CSV example. So I'm going to click that. Successfully loaded military.csv to df military. This is a snapshot of my military from a game of Dwarf Fortress. It's not a particularly good snapshot, but it's coming from that little file right there. And we will go over and look. Yeah, there they are. So this is all loaded from a CSV. No problem loading from a CSV as long as you can get the data into your record set. And then we have one more example, which is, I think, more obnoxious. And this is, we are going to load a table. What table are we going to load? We're going to load this table of area codes and things like that from someone's website. So we go over here and we do that. Loaded it to dbo.areacodes. And there they all are. So anything you can get into a data set, you can ETL. And that's the way that tools should always work, in my opinion. All right, so that is that demo. We are just about done, and then I will take any questions that people might have. Yes, I wanted to just quickly talk about dynamic SQL because I am using dynamic SQL, and that may make some of you nervous, understandably so. First of all, of course, when you're dealing with it, you want to sanitize your inputs, escape your strings, and so forth. If you control the collations, this should be entirely doable. Most of the weird exploits that I see these days, as far as SQL injection, come from people using analogs to quotes in different UTF. I can't think of what they're called, schemas or whatever they might be. So doing a find replace might be difficult there, but if you control the collation, it's just a standard Latin collation. You're just dealing with ANSI or ASCII text. Totally doable. You can also use parameters for everything. The problem on that is that the upper limit on parameters is 2100. I said about 2100 because I don't know, maybe I'm wrong on that, but it's 2100. I will also mention, though, that the SQL injection risk from a numeric type is exactly 0. Can't do a SQL injection with a number. So no need to worry about parameterizing those. That could make the use of parameters more reasonable if you only have to use them for string types, which is exactly what you can do. Use parameters for all string values. It's practical if you have duplicate values and are tokenizing everything anyway, in particular, but it could be practical in other scenarios too. It may just mean that you have to use smaller batch sizes if you're doing that. Then, of course, you have my personal favorite way of dealing with SQL injection, which is cast all strings to var binary. If you're putting it in as just a binary string, there's no risk of SQL injection whatsoever. And since you're handwriting some of that SQL in SSMS anyway, casting it back to a varchar or an nvarchar when you're actually loading it, it's trivial to do. So that's my personal favorite way to avoid SQL injection. Finally, I did promise this one, handling slow linked server queries. So some things that I will mention, just query a replica. Please don't query, don't use your transactional data stores for queries. Yeah, query the replica. Of course, that's not always available. All right, fine. Use snapshot isolation if you must query a live production system. That's also not always available. All right, fine. Well, we talked about this already. Cache your OPENQUERY results to temp tables. If you are not joining across the linked server, you don't have to worry about network latency. So just load everything to TempDB and then do your joins. Make sure you index the tables appropriately, though, or you're still not doing any real favors. And then finally, you can always cache and index your local tables if necessary. So you take that core table on your production database, kick it over to TempDB, and then do your joins on that. Now, all of you DBAs out there are saying that I'm a monster and I should never be allowed near TempDB again, and you're probably right. This is unfortunately just the tip of the iceberg of the crimes I commit against TempDB, but business needs are there, and I'll be happy to take DB owner permissions anytime you're ready. So that concludes the presentation here, and I'm happy to take any questions that there might be.
Well, that was great. I actually like the way that you phrased that. So that's a lot of fun. I don't have too many questions. I got some great comments from about your presentation. So if anyone else has stuff that they want to post in, I know someone did try did ask the code.cursors are evil.com. I did post that in the chat as well. Just so you know, it does resolve to a GitHub link. So don't be surprised if that happens. And then you should see the presentation repo from there. I did test to make sure I typed in the right thing. So hopefully, I think Curtis, you had asked about that. Hopefully you're able to find it. If not, we will be making this available later, so you'll be able to see that. But I don't see any other questions right now. Anyone have anything that last chance to get in while you're live? Oh, we just got another one. Given SSIS is free with Visual Studio Community Edition and connects to Excel, Access, SQL, etc., why not use it?
That is a fantastic question. And as a matter of fact, Rich, if I had access to SSIS on my corporate network, despite the fact that it was free with Community Edition, and in fact, it's just available out there, I would have used it and I would have never ended up developing any of this. But it's not always available, particularly in some of these enterprise environments, unless you are in an official developer or a DBA role. That being said, every time that I have benchmarked this against SSIS, I have won. Now, that's not always true, and it's certainly not worth, like, as I said, if the performance difference is 10 seconds, why not use something that's quicker to set up? You're right. You should use SSIS. If that's the available option there and you already have that infrastructure set up, by all means use it. But the other application of this, though, is embedding these approaches into other sorts of applications. So if you're not just doing pure ETL, if you are developing, a desktop application, for example, or an end user computing tool for other power users, or even just other users in your organization, you can include these tools in there. And I will say that this makes cross database querying a lot easier. One of the use cases that we have is 3 basically different major database systems that all refer to the same underlying business entity, I guess. So, you have like legal information about something, you have financial information about it, and then in the case of the business that I came from, you'd have like information about collateral, so underlying stuff, right? And those are stored on 3 different systems. two Oracle databases and a SQL Server database, as a matter of fact? Well, you find the smallest data sets and you spool those over to the one that has the biggest, most painful thing. And that query can take just a matter of a second or two if you're loading the data in place. Whereas if you're trying to pull down everything and do your joins locally, you can have some really ugly performance there, minutes or even in some cases hours.
Yeah, that's a great reason for doing that. There's a lot of great stuff in this presentation together. Just put the reminder that this is being recorded, and so you'll be able to watch this again if you missed anything, because there's a lot to catch. I also reposted the URL for the scripts again, if you missed that earlier. And I'm trying to say, I don't see any other new questions pop up, but Courtney, did you say that this was your first presentation in the community?
Yes, it is. It is.
Fantastic. Someone else had mentioned this, but this was a really great presentation, and kudos to you. You did a great job. This is a lot of great stuff. So congratulations on that.
Well, thank you. And thank you everybody who attended. I hope you got something out of it, share it with your friends, all that sort of thing. Yeah, and you go to cursorsareevil.com. It was really kind of a lark that I created the domain name over the last week. It is kind of a slogan of mine. I will actually turn it into a website that doesn't just redirect to my LinkedIn and to my GitHub repository. But if anyone has any questions about any of this, please feel free to reach out.
And it's amazing that was still available. It's great that you got that. So again, this will be available on the YouTube later if you need to catch it again, and definitely follow up and with Courtney if you have any questions. So at this point, there's going to be a small break in the schedule. The next session is on, I believe, at 2 p.m. Eastern. I'm trying to remember was it 6 p.m. UTC time? So definitely check out the website, because there'll be a small break for about an hour. We have Rob Richardson's coming up next, a database DevOps pipeline. And make sure you catch all of these. There's so many great presentations at GroupBy. So it'll be a short break. And thank you all so much for joining.